So we simply multiply the 3x into the brackets. And of course, we have 3x times 2x squared is 6x cubed. Then we have a minus. 3x times 5x is 15x squared. Then another minus. And 3x times 4 is 12x. So multiplying the negative 7y into the brackets. Negative 7y times 2xy is negative 14xy squared. Then a minus times a minus is a plus. And 7y times 4x is 28xy. We multiply the half into the brackets. So a half times a is a half a. Plus a half times b is a half b. Then 4a times a quarter. We can write a 4a as 4a over 1. In other words, as a fraction as well. Then 4 into itself once and into 4 here once. Now we can multiply the numerators. So we have 1a times 1, which is just a, over 1 times 1, which is 1. So here we're left with a only. Now we can add like terms. A half a minus 1a. So it's a half minus 1 is of course negative a half. And this one could do on the calculator. So then a half a minus 1a is negative a half a. And similarly, a half b minus 1b is negative a half b. We can start by multiplying the a here into the second set of brackets. A times a squared is a cubed. Then we have a minus. A times 2a is 2a squared. Then we have a plus. And a times 4 is 4a. Now we multiply the 2 into the second set of brackets. So 2 times a squared is 2a squared. Then positive 2 times negative 2a is negative 4a. And positive 2 times positive 4 is positive 8. Now we simply add the like terms. So negative 2a squared plus 2a squared, these two terms will cancel. It's the same term, but with opposite signs. So the same with 4a and negative 4a. They also cancel, and we're left with plus 8. We can use FOIL to multiply out these brackets. So we can multiply 2x by x, and then by negative 3. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. Then positive 5 times x is positive 5x. And positive 5 times negative 3 is negative 15. Here we can either use FOIL or we can use the shortcut method. I'm going to use the shortcut method. This, of course, is a perfect square. So we square the first term. Then it's the first term times the second term times 2 with this sign, so a negative. So x times 1 is x times 2 is 2x. And then we square the second term, so plus 1. Note that we don't need brackets around these terms, because we have a plus here. If we had a minus, we would need brackets. So in this case, we don't need brackets. Now we can add like terms. So 2x squared plus x squared is 3x squared. Then we have negative 6x plus 5x is negative 1x, minus 2x is negative 3x. Then negative 15 plus 1 is negative 14. Here they want to know whether this statement is correct, and it says, show by calculation to prove your answer. What's quite important to note is that when we have a plus b all squared, this is never equal to the first term squared plus the second term squared. The same with a minus b. A minus b all squared is not equal to the first term squared minus the second term squared. Remember that a plus b all squared using the shortcut method will be the first term squared, then this sign, then the first term times the second term times 2. So a times b, which is ab, times 2, which is 2ab. Then plus the second term squared. If you have a minus here, then all that happens is that this sign will be negative. Now, let's apply it to this product, 2x minus 1 all squared. So 2x minus 1 all squared. We can use the shortcut method. So it's the first term squared, which is 4x squared. Then this sign. Then 2x times 1, which is 2x, times 2, which is 4x. Then plus the second term squared, which is 1. So 2x minus 1 all squared equals this here, and it's not equal to 4x squared plus 1. You could, of course, also have used the long method using FOIL to square out these brackets, and you will get the same answer. The last question here is a non-routine or high degree of difficulty type question. We're given this expression in x, so they say using this expression, determine the value of this expression. Now, we want to look at this expression here with these numbers a little bit more carefully. We have 54,321 all squared. Now, if I look at 54,323, then it's actually 54,321 plus 2. So 54323 is 54321 plus 2. Then if you look at 54319, then it's 54321 minus 2. Now, we can see that basically this expression here with these numbers is the same as this over here. Instead of x, we have 54321. So for x plus 2, we have 54321 plus 2. Then for x minus 2, or in the place of x minus 2, we have 54321 minus 2. So essentially, the 54321 is nothing but x. So we have x squared, then we have x plus 2, then we have x minus 2. So as we said, these two expressions are essentially the same. So let's simplify the expression in x and see what we get. So we have x squared. So I'm first going to rewrite this. X squared minus x plus 2 times x minus 2. So we have x squared, then minus, and this of course is a difference of squares. So I'm going to put it in brackets because of the minus here. So we square the first term, then minus, and we square the second term. Then simplifying, we can multiply the minus into the brackets. And here the x's squared will cancel. So the answer is equal to 4. It means that this expression, the one in x, is independent of the value of x, because the answer is 4. No matter which value of x I plug in here, I will get 4. And since the second expression is essentially the same as the first one, the answer is also 4. So now we can say, therefore, the expression that we want to evaluate, this one, is also equal to 4.